So remind me what determines the end behavior of a polynomial. Which exponent? Not necessarily the first one, the biggest one. Because it might be scrambled, and if you scramble a polynomial, that doesn't change the graph, but it might change the order. So it's the biggest exponent. And what is it about that biggest exponent that affects the end behavior? Odd or even, and positive or negative. So if we have a negative x to an even power, what is the end behavior? They both go down. So that would look something like this, or like this, or you could even have a bunch more of those, something like that. What if I have a positive x to an even number? Then it would look like this. Something like that. And again, there are arrows on all of those. Okay? What about a negative x to an odd power? So it's going to start from the top and then go down. Or it could do a couple wiggles in there, or a lot more. What about x to the first? Is it true of x to the first? It's a straight line, but does it follow the end behavior? Yes. It would be some line with a negative slope. And the end behavior is the same. So what about positive x to an odd number? It's going to start down and go up. And it could have a couple wiggles in there. And so on. Now that's going to help you on both of the assignments today. If you know this, you don't need to graph anything on this first worksheet. So if we look at number 1, I can go ahead and scribble out the rest of that polynomial. All of those other numbers will change the shape of the graph, but it will not affect the end behavior. So those other numbers will stretch it out and add those wiggles we talked about and move it left and right and move it up and down, but they cannot change the end behavior. The end behavior is dictated entirely by the biggest exponent. And in this case, they're both going to be going down. And we need to write these in limit notation. So the limit of f of x as x goes to the right, which would be positive infinity, what happens to f of x? It's going down. It's going to be something like this. So as we go to the right, we're going down. So as x goes to infinity, f of x goes to negative infinity. And then the other part is the limit of f of x as x goes to the left, which is negative infinity. So on this same graph, if we go to the left, what happens to the graph? The graph is going down, so this one is also negative infinity. Yes? There isn't. Well, I'll tell you what. If you just want to do, as x approaches infinity, f of x approaches negative infinity on this worksheet, I'd be okay with it. But on the test, it needs to have the limit notation. Limit of f of x as x approaches negative infinity is negative infinity. So as x moves to the left, my y value goes down. So as x moves left, the y value moves down. Yes. What's that? It is hot in here. Think we've broken the record. We're up to 83. It's hot. So let's look at number 3. So number 3, the limit as x goes to the right. This is an odd, which means one side is up and one side is down, but it's a negative odd. So as we go to the right, is the graph going to go up or down? Down. So f of x equals negative infinity. And the other one is the limit of f of x as x goes to the left, which is negative infinity. So the graph is going to look something like this. So as I move to the left, the graph goes up. So this is infinity. Okay, now look at your, well, you're still going to take notes, but on the other one, it gives you an equation and it wants you to graph it without using your calculator, which is actually really easy to do if you know the roots. So let's suppose we had f of x equals x plus 1 and x minus 7. This is just notes. I don't care where you put it. I'm just making up an equation. So what are the roots associated with these factors? Negative 1 and 7. Now, this is going to be an x squared graph. Is it a positive x squared or a negative x squared? Well, there's nothing there, so that's a positive, and I have positive x times positive x, so it will be positive x squared. So I know that the graph looks like this. I also know that it hits the x-axis at negative 1 and 7. So negative 1 and positive 7. That's what the graph looks like. That was easy. Okay. What about this? Good. That x is a 0, so my roots are negative 1, 4, and 0. Is this a positive x to the third or a negative x to the third? Positive x to the third. So it's going to look something like this. My roots are negative 1, 0, and positive 4. So I know that the graph looks like it goes down on the left and up on the right. So it's going to look like that. It's the general idea, yeah. What's important is you get the end behavior right and you get the roots right. Because technically, if I made the graph steeper, it still satisfies everything I need. And that can be changed by adding a 2 or a 3 or something like that in the front. But we don't care how steep it is. We care that the end behavior is right and that the roots are right. Okay? G of x equals so what are my roots? 3, negative 2, and 1. What type of graph am I looking at? A negative x to the third, so it's going to look something like that. So we have a negative 2, a 1, and a 3. So it's got to start from the top and look like that. That negative 2, 1, and 3, and it's a negative graph. So are you wondering why I didn't draw it this way? So those are my roots. And that one goes there. Okay. Now, something a little bit tricky. So this graph, I don't know the roots. So I just factor x and x. Two numbers that multiply to be 9 and add to be -6. -3 and -3. So what are my roots? And +3 and +3. Is that possible? So it's not a straight line because it's a quadratic, so it has to be U-shaped. So let's look at, let's suppose I had a quadratic where those are the roots. So my roots here are 1 and, what is that, 6? If I move that quadratic up, my roots are now 2 and 5, 4, well, this is, but anyway, if I move it up enough, what are my roots? 3 and 3. So whenever you have a double root, sometimes they refer to this as multiplicity. 3 has a multiplicity of 2, meaning there are two versions of the root 3. Whenever you have a double root, the graph goes down and bounces off the axis and changes directions. So, if I were to make things a little bit more complicated, x minus 1 squared and x plus 4, what are my roots? Well, -4 is one of them, and 1 and 1 again, because it's x minus 1 squared. So I have two x minus 1s. So we know when there's a double root, the graph is going to bounce off the axis and change directions. The question is, what direction was it moving in to begin with? Well, we need to look at the graph. So -4 is over here, and then 1 is right there. And what type of graph is this? Positive x to the third. So it's going to look like this. So I'm going to start down low. Do I go through 4 or bounce off of 4? Through 4. And then I come down and bounce off the 1 and go up. That wasn't too bad, right? No, not really. Oh, wait a minute, wait a minute. I forgot. Okay. So I'm going to bounce off of my first root, which is 3 and 3. And then I have a root of 0. And then I have two -1s. What type of graph is this? -x to the 5th. So it's going to look like this. Well, it might have some wiggles in there, but as far as end behavior, it's going to go that way and that way. So -1 is a double, 0 is a single, and 3 is a double. -1, 0, and 3. Where do I start? I start high. So I come down to 1. Am I going to go through it or bounce off of it? Bounce off of 1. Go straight through 0. And go towards 3, hit it, and go down. Anybody know what happens when you have a triple root? You just die. it's over. A triple root looks like this. Suppose I had x minus 2 to the third. So it's going to come up towards, and it's going to saddle out and go up again. So that represents 3 different roots. It slowed down as it got, well, it slowed down as it got close to it. It did go through it, and then it sped up again. 4 would be a bounce, and 5 would be a saddle. 20 is even, so 20 would bounce off. 23 is odd, so it would pass through. But if you were to get 23, that graph is so steep, it would look like that. Because it's climbing so fast. If you were to zoom way out, then it would look like this. 23 would. So even roots, even numbered roots bounce off, and odd number roots power through. And then it gets a little bit more complicated when you introduce imaginary roots. No, but I'll just show you. So an imaginary root, so that is a real root, that is a double root. An imaginary root would look like that. It changed directions, but it didn't hit the x-axis. So this is a single root, -2. This is a double root, -1 and -1. And we know there are 2 more roots, at least, because we changed direction 1, 2 times. So that would be something like x minus 3i and x plus 3i, I'm just guessing. And there could be more, because this could actually be a triple. So sometimes the double and the triple roots hide themselves. It might look like a double, but it's a quadruple. It might look like a triple, but there are actually 5 of them. And then the imaginary roots are really hard to find unless you know the equation. Okay, so let's do this. Can I factor anything out of this? I could pull a 2, but a 2 is not going to be good enough. I could pull a 2x, but that's not going to be good enough. Negative. Why do I want to pull out a negative? Right. I want my biggest x to be positive. So I pull out a -2x. What am I left with? X squared. I took the negative out and the 2 out and one of the x's. Plus 3x minus 10. What is this going to do to the graph? It will change it. It'll change it from a positive x to the third to a negative x. So it's going to move it from here to here. What is that x going to give me? It's a 0. It's the root 0. Okay? Can I factor this? X plus and x minus. So my options are 1 and 10 and 2 and 5. 5 and 2, which gives me the roots, -5 and +2. So now I can graph it. It hits at -5, it hits at 0, and it hits at +2. Am I going to start high or start low? Start high because it's a -x to the third. That would be my graph. The 2, that's a good question. What does the 2 do? The 2 actually makes it twice as steep. So if I were to divide out the 2's, it might be a little less steep. But it's not going to change the end behavior. And so we don't really care what the steepness is. Okay.